We're solving inequalities today, and remember, an inequality is a little bit different than an equation, because in an equation you'll usually have one or two numbers that make this true, but in an inequality you have an infinite number of numbers that make this true. So there's lots of different values I could put in for x that would make this greater than 3.6. If this was equal to, there would only be a couple values that would make it true. But because I'm looking for numbers greater than 3.6, I have a huge, in fact, an infinite number. So the answer to an inequality is always going to be an interval, a range of values. So maybe it's going to be like negative infinity to 5 and 7 to infinity, or maybe it's going to be from negative 5 to 7 or something like that. But it's always going to be a range of values. It's never going to be one number. So if you remember what inequalities mean, we look at this and we say, okay, all of this stuff inside, once I solve it and take the absolute value of it, it has to be greater than 3.6. So all this stuff inside could be negative 3.6 as well, right? So it could be negative number because when I take the absolute value of it, it's going to be positive. And if we think about a number line, we think about, here's 3.6 on the number line, and here's 0. And so numbers that are greater than 3.6 are going to be like these numbers over here, right? But numbers whose absolute value are greater than 3.6, think about where they would be. They'd be over here, wouldn't they? So any number that's less than negative 3.6 is also going to have an absolute value greater than 3.6 because absolute value is really just talking about distance. So we're looking for numbers that are farther away from 0 than 3.6, if that makes sense. So what I do is when I'm going to solve this, I split it into two options. So we have 2x minus 1 is greater than 3.6 is one of our options. And then the other option is that 2x minus 1, all the stuff inside the absolute value, has to be less than negative 3.6 because that would make it further away from 0. That would make the absolute value of it greater than 3.6. Okay, so we solve both of these. And remember, the main rule is that if we multiply or divide by a negative number, we have to flip the sign. So we add 1 and we have 2x is greater than 4.6, divide by 2, divide by 2. We get x is greater than 2.3. So that's one of our answers. And then we add 1, so we have 2x is less than, and this becomes negative 2.6. And then we divide by 2, and x is less than negative 1.3. See, we divided by a positive number, right? Because we actually divided by 2, so we don't flip the sign for that one. So our two answers are x either has to be less than negative 1.3 or greater than 2.3. So to graph that, we have a beautiful number line here. Oh, much better than my last one. Okay, I have 0, negative 1, negative 2, negative 3. And so we're going to have to be greater than 2.3. And I'm going to do an open circle because I'm not going to be equal to 2.3, but I'm going to be greater than it. So I go that way. Or less than negative 1.3, and again I'm going to leave an open circle and I'm going to go this way. So that's my graph, and then how do I write it in interval notation? Well, I would say, let's see, x is less than negative 1.3 means every number all the way from negative infinity to negative 1.3. So I'm going to write it as negative infinity to negative 1.3 parentheses because we don't include negative 1.3 because it's just less than, not less than or equal to. And then I draw this little u, and that little u just means a union, and it means this or that. You'll learn that if you ever go into computer science, they use a lot of the union things like that. Anyway, so then we go from 2.3 all the way to infinity. And remember, infinity is not a number, so it always has an open bracket. So let's try another one. Here's an inequality. So remember, all that stuff in the middle, all this stuff in the middle has to either be less than 5. Here's 5. Here's 0, here's negative 5. So all the stuff in the middle has to be closer to 0 than 5, which means it needs to be less than 5 or greater than negative 5. Okay? Because that would make the absolute value of it closer to 0 than 5. Okay, so our two options are x plus 3 is less than or equal to 5, and our other option is x plus 3 is greater than or equal to negative 5. So we subtract 3, I almost said add 3. We subtract 3 from both sides, we get x is less than or equal to negative 2, and x is greater than or equal to negative 8. So these are our two options. Either one of those would make them true. And again, it's a range of values, so it's not just 2 and negative 8 that make it true. It's any number smaller than 2 and any number bigger than negative 8. So it could be like literally, you know, any number, even a decimal in the middle of those two would still work. I didn't make a very big number line. So we're going to make it nice and beautiful there. So we're going to go bigger than negative 8, and this time it says less than or equal to, so we're going to have to make a closed circle. And if you remember, that means greater than negative 8 means going this way, and less than or equal to 2 means going this way, so we have to figure out where they overlap. So where do those two have the same numbers in common? That would be right here. So to graph it, we just graph those closed circles and then draw the line in between. We don't need to do the little blue scribbly. That was just kind of my showing you how to do it, but that would be the solution to this equation, any number in between negative 8 and 2. And let's write it in interval notation. So that means from negative 8 to 2, and we're going to use close brackets since both of them are equal to. All right, finally we have this one. Again, we're just going to write it in two options. So we have x plus 2 over 3 is greater than 3, or x plus 2, I'll do it in a different color, x plus 2 over 3 is less than or equal to negative 3. So those are our two options. We multiply both sides by 3, and I get x plus 2 is greater than or equal to 9. X plus 2 is less than or equal to negative 9. Then I subtract 2, so I have x is greater than or equal to 7, and then I have x is less than or equal to negative 11, so those are my two options. To graph this one, I would just take a graph. We're looking at numbers greater than 7, greater than or equal to 7, and less than or equal to negative 11, so I'm not going to go ahead and number this whole thing properly. You should, especially on any assignments, but say that's 7. That's negative 11. So negative 11, we're going to do a closed circle, and we're going to go that way. And positive 7, we're going to do a closed circle as well because it's greater than or equal to, and we're going to go that way. So it's either or, which means we can write it in interval notation. We can write from negative infinity to negative 11, closed bracket, or, we need a closed bracket on the 7. Close bracket on 7 to infinity. So that is how you solve and graph absolute value equations, or inequalities.